Hey everyone, welcome back to another video by Cam Room 5. Today's video is going to include some past paper questions from IGCSE and O-level examination from GCSE, and we'll see how to answer those challenging questions. I'll try to talk more about some extra details, but I'll try to keep everything as quick as possible for more content and less time. Like this question says, how hydrocarbons are compounds which contain carbon and hydrogen. 10 centimeter cube of gaseous hydrocarbon are burned in 100 centimeter cube of oxygen, which is an excess. Excess means some of it is left unreacted after the reaction. Left unreacted after the reaction. After cooling to room temperature and pressure, there is 25 centimeter cube of unreacted oxygen, which means 75 centimeter cube reacted. Now moving on. 50 centimeter cube of carbon dioxide and some liquid water. So you also have 50 centimeter cube of carbon dioxide with you. All volumes are measured under the same conditions of temperature and pressure. What is meant by an excess of oxygen? So we've already said that some of it is left unreacted after the reaction. What was the volume of oxygen that reacted with the hydrocarbon? So we notice that 100 centimeter cube was added and 25 centimeter cube was remaining, so 75 centimeter cube reacted. Complete the table to show to express the smallest whole number ratio of. So how much hydrocarbon was reacted? So you notice it was 10 centimeter cube. How much oxygen reacted? So it was 75 centimeter cube. Volume of carbon dioxide produced, so it was 50 centimeter cube. If we take a ratio of that, it becomes 1, 7.5, and then it becomes 5. We can't do 7.5 because they're considering whole numbers. So what do? We multiply everything by 2. So double hydrocarbons, 15 oxygen, and 10 carbon dioxide. Use your answer to A3 to find the mole ratio in the equation below. Complete the equation and deduce the formula of the hydrocarbon. So when two hydrocarbons react with 15 oxygen, you get 10 carbon dioxides. You don't know how much water was there. Now it is really important to do some arithmetic over here. You can see that 10 carbon dioxide involve 10 carbon atoms. So in 2 times hydrocarbon, you had 10 carbon atoms because all the carbon is coming from the hydrocarbon. So 10 carbon atoms were present in 2 moles of the hydrocarbon. 1 mole of hydrocarbon would have 5 carbon atoms. So X is equals to 5. X is equals to 5 for sure. Now moving on, how much water is there? How much hydrogens were there? So notice one thing. 15 oxygens were used, which means 30 oxygen atoms. Out of these 30, 20 went for the carbon dioxide because each carbon dioxide, 10 carbon dioxide, involves 20 atoms of oxygen. So 10 carbon dioxide means out of these 30 atoms of oxygen, 20 were used up for the carbon dioxide, and how much is left? 10 is left. So 10 oxygen atoms would be used up in water. Each water molecule needs 1 oxygen atom because the formula is H2O, only 1 oxygen is needed. So 10 oxygen atoms which are used to make water will make 10 water molecules, right? So how much hydrogen is there? 20 hydrogen atoms. It means 20 hydrogen atoms were here. So 2 times the equation, 2 times the hydrocarbon involves 20 hydrogen atoms. It means a single hydrocarbon will involve 10 hydrogen atoms. So Y is equals to 10. So it means the formula is C5H10. I would really recommend you guys rewatching this portion if you guys had any difficulty with the quick math here. Now moving on. Cracking is used to convert long chain alkanes into shorter chain alkanes and alkenes. Decane can be cracked to give propene and one other product. You just have to complete the equation. So if carbon was 10 atoms and 3 has been used up to make the product, How much is left? 7. So C, 7 should be here. If you had 22 hydrogen atoms and 6 have been used up, it means 16 are left. So C7H16, which is obviously the name for heptane. Moving on, what is meant by the term unsaturated? It contains one or more carbon-carbon double bonds. Describe a test to show that propene is unsaturated. Use bromine water, and if it is actually unsaturated, it decolorizes. It decolorizes from orange brown to colorless. Propene can be polymerized. Propene, by the way, is an alkene. It can be polymerized. The only product is polypropene. The equation for the polymerization is, it's already given. N means any integer. Name the type of polymerization that occurs. So you can notice alkenes only give addition reactions. So here you can say the polymerization is addition polymerization. Moving on. Deduce the maximum mass of polypropene that could be produced from 1 kg of propene. In addition reactions, there are no byproducts. No water, nothing. So all propene is only making polypropene. You have no byproduct. So no loss of mass. No loss of mass here. So you get 1 kg polypropene. Give the empirical formula for propene. So propene has a formula C3H6. If we take a ratio, we get CH2. Even if we talk about polypropene, you can clearly see that it has a similar formula. There is no byproduct. So polypropene also has the same empirical formula. Moving on. Carbon and silicon are elements of group 4 of the periodic table. Both carbon and silicon exist as more than one isotope. Isotope means same protons and different neutrons in the atom or in the nucleus, or you can say same atomic number and different atomic mass of atoms. So those are two definitions of isotopes. Complete the following table. So when they talk about carbon, we know carbon has how many protons? Carbon has 6 protons, which is fixed. Silicon has 12 protons, which is fixed. Nucleon number. Silicon has 14 protons. 12 was magnesium. Electronic structure. So electronic structures mean configuration. So it is 2, 4. It is 2, 8, 4. 4 in the end means they are both in group 4. Or if you were A-level student, you would say group 14. Nucleon number is already given, number of neutrons. So how do we find neutrons? It has to be 12 minus 6, which means 6 neutrons here. It's 28 minus 14, which means 14 neutrons in silicon. Name the type of bond which is present between silicon atoms in silicon. Silicon, you should know, represents a giant covalent structure. It's a giant covalent structure, so you will say covalent bonds are here. Suggest 2 physical properties of silicon. Use your knowledge of structure and bonding. So giant covalent structure means high melting point, boiling point. The reason is large number of very strong covalent bonds. I'm writing in like short form, but you can't do that in your actual examination. When we talk about another property, so they are do not conduct electricity. Don't involve the idea of semiconduction here, because in O levels we don't talk about that. So you can say it does not conduct electricity because all valence electrons occupied in bonding. All valence electrons are occupied in bonding, so no mobile electrons. So samples of air taken from industrial areas are found to contain small amounts of carbon monoxide. Carbon monoxide looks like this. Explain how carbon monoxide is formed. So you can say incomplete combustion of fuels. That is enough because you're talking about incomplete and you're talking about combustion of fuels. State why carbon monoxide should not be inhaled, as it causes breathing problems. How? Because it combines with hemoglobin protein and affects oxygen transport. In your body, oxygen has to be transported to tissues for your muscles and your body tissues to respire. But if carbon monoxide is there, it compromises the oxygen transport. Carbon monoxide is a gas at room temperature and pressure, whereas silicon is a solid. Name the type of structure which the following compounds have. So carbon dioxide, CO2 is a simple covalent molecule. And when you talk about silicon dioxide, you should say that it's a giant covalent molecule. It's a giant covalent molecule. Use your knowledge of structure and bonding to explain why carbon dioxide is a gas at room temperature, whereas silicon dioxide is a solid. So first talk about carbon dioxide. CO2 has simple molecules with weak intermolecular forces between them, which are easy to overcome. Now next sentence should be about silicon dioxide, so you should say SiO2 is a giant molecule with many strong bonds which are hard to break. Notice the terminology I'm using here. I'm saying overcome with weak intermolecular forces and hard to break with strong bonds. Moving on. Silicon oxide is an acidic oxide. When silicon oxide reacts with alkalis, the salt formed contains the ion SiO3 twice, which is known as silicate ion. Write a chemical equation for the reaction between silicon 4 oxide and aqueous sodium hydroxide. So silicon dioxide reacts with sodium hydroxide. What do you get? From sodium hydroxide you get Na plus and OH minus. And when you talk about silicon dioxide, they've already mentioned you get SiO3 2 minus ion. So the combination should involve sodium and silicate. So your product should involve sodium and silicate. What's the formula? So you will do the cross multiplication and you get Na twice SiO3, which is known as sodium silicate. So your first product is sodium silicate, and that involves the balance equation. What is left behind, because in each neutralization you get something also, you get water. In order to balance it, you can clearly see you need double sodiums and double H's. So you twice the sodium hydroxide. This is known as sodium silicate. Moving on. The elements in group 7 are known as the halogens. Some halogens react with aqueous solutions of halide. Halide means fluoride, chloride, bromide or iodide, the negative ions. Complete the table by adding a tick to indicate when a reaction occurs and a cross to indicate when no reaction occurs. If you add chlorine with potassium bromide, they've already put a tick here. You can see that. Oh, sorry. You can see that. When chlorine reacts with potassium iodide, so chlorine is highest in the reactivity series of halogens, or I should rather write it more simply by saying chlorine is most reactive among these three. So chlorine will indeed react. Iodine is the least reactive, so iodine does not react, does not react. Iodine is least reactive. Bromine is more reactive than iodine, so bromine reacts with potassium iodide but does not react with potassium chloride. Write a chemical equation for the reaction between chlorine and aqueous potassium bromide. So chlorine, which is Cl2, and aqueous potassium bromide, which is KBr. So KBr. Since chlorine is more reactive, chlorine replaces or displaces the bromide and make potassium chloride. What happens to the bromine? Bromine is left alone. So what is the other product you get? You get bromine, which is Br2, and potassium chloride. To balance this equation, we add a double before potassium bromide and double before potassium chloride. The state symbols would involve chlorine, potassium bromide is aqueous, potassium chloride is aqueous, bromine produced can be liquid in the solution. A sample of vanadium chloride was weighed and dissolved in water in excess of aqueous silver nitrate. Acidified with dilute nitric acid was added. A precipitate of silver chloride, which means silver chloride, was formed. The ionic equation for this reaction is shown. The mass of silver chloride formed was 2.87 gram. State the color of the precipitate. So silver chloride is white precipitate. Just reminding you that silver chloride is equals to white, silver bromide is equals to cream, and silver iodide is equals to yellow. The relative formula mass of silver chloride is 143.5. Calculate the number of moles in 2.87 gram of silver chloride. So we'll use the calculator here, and 2.87 divided by 143.5. So that gives me mole is equals to mass over mR 0.0200. Why am I putting two extra zeros? That is three significant figures. Use your answer and the ionic equation to deduce the number of moles of chloride ions that produced 2.87 gram of silver chloride. You can see that silver chloride and chloride have a 1:1 ratio. So number of moles of silver chloride and number of moles of chloride ions are 1:1. So it should mean that same mole of chloride ions were there. The amount of vanadium chloride in the sample was 0.01 moles. Use this and your answer to B3 to deduce the whole number ratio of the moles of vanadium chloride to the ratio of moles of chloride ions. So how many moles of vanadium chloride? They have already said 0.01 moles. How many chloride ions? 0.02 moles. We take a ratio and then we get 1:2. So it means the formula was VCl2. It means each vanadium chloride had double chloride. So the only formula that fits is VCl2. Astatine is at the bottom of group 7. Use your knowledge of the properties of the halogens to predict the physical state of astatine. Astatine is at the bottom, which means it is going to be a solid, because in group 17 you move from gases to solids. Write a chemical equation for the reaction between sodium and astatine. So sodium is Na, astatine is always diatomic because all halogens are diatomic. What do you get? You get sodium astatide. Sodium has a charge of +1, astatide is -1. To balance this equation, I will simply double the sodium and double the sodium acetate. Iodine reacts with chlorine. The chemical equation is shown. Use the bond energies to answer the questions. Calculate the total amount of energy required to break 1 mole of I2 and 1 mole of Ca2. So bond breaking is equals to 151 joule required to break 150 kilojoule required to break II bond and 242 required to break the Cl-Cl bond. So we simply just add that 151 plus 242, it's 393 kJ. Calculate the total amount of energy given out when the bonds in 2 mole of ICl are formed. So ICl is 208. Bond making is equals to 208 times 2, which gives you 416 kilojoule. Since it's bond making, it should be negative, but they're just concerned with the energy. Use your answers to D1 and D2 to calculate the overall energy. So what do? Enthalpy is equals to bond breaking minus bond making. Bond breaking was 393. Bond making was 416. So when you do that, 416 subtracted minus 23 kilojoule. I hope these questions are clear to you. In the next video, we are doing some more questions of similar sort. Stay tuned, guys. Thanks.